You're listening to the Cyberwire Network, powered by N2K.
The IT world used to be simpler. You only had to secure and manage environments that you controlled. Then came new technologies and new ways to work. Now, employees, apps, and networks are everywhere. This means poor visibility, security gaps, and added risk. That's why Cloudflare created the first-ever connectivity cloud. Visit cloudflare.com to protect your business everywhere you do business. Hello, everyone, and welcome to the CyberWire's Research Saturday. I'm Dave Bittner, and this is our weekly conversation with researchers and analysts tracking down the threats and vulnerabilities, solving some of the hard problems, and protecting ourselves in a rapidly evolving cyberspace. Thanks for joining us.
So in this case, the detection was triggered by a machine learning model, and we have a review procedure of those detections to see which are true positives and determine what type of malware, in this case, we had.
That's Carlos Zanke, reverse engineer at ReversingLabs. The research we're discussing today is titled Malicious PyPI Crypto Pay Package Implants Info Stealer Code. So you get that indication from the automation, and what motivated your team to dig deeper into the package?
Well, in this case, we had a package we have previously seen to have clean versions. So usually when we encounter most of the malware in public package repositories, you encounter new packages. So somebody publishes a new package which is immediately malicious in the first or second version. In this case, we had a package that was, let's say, maintained for some time, for several months, since I believe beginning of September or something like that. And usually, when you see such a package that has several months of maintenance, they are not always true positives. More often, it happens that they are false positives. So those are packages that use malicious looking behaviors in a legitimate way. But in this case, we took a detailed look and spotted well observed obfuscation pattern of base 64 encoding and zlib compression. So when we encounter something like that, even though sometimes you find something using it in legitimate purposes, most often it is malware.
Well, what was the process for deobfuscating the code, and what sort of things did you uncover once that obfuscation was stripped away?
Well, this is not, it's Python, it's scripting language, so it's fast to write your own code to decrypt something like this. It's basically several rounds of base 64 decoding and reversing string and doing zlib decompression. So you do what the attacker did just in reverse order. So it's not hard to perform the obfuscation if you have a little of coding experience. And what we observed is that we had malicious code aiming to steal sensitive information relating to crypto trading. So the goal was financial gain. Most often we see in latest time threat actors try to steal cryptocurrencies and secrets related to cryptocurrency trading to quickly get to financial gain.
Well, I mean, looking at some of the threat actors' tactics, how was the AIO CPA campaign different than some of the more common supply chain attacks? Things like typosquatting or impersonation. Were there some differentiators here?
Yeah, well, as you said, typosquatting is the most common way. You take a popular package and typosquat it, or try to impersonate it, but add a suffix to the name. Let's say a legacy. I don't know, something related to either Bitcoin, Ethereum, or anything like that, and add some suffix to make it look like a fork of a legitimate project, and hope that somebody will use it. And those are two most common ways of infecting targets. But in this case, we had a developer creating his own crypto trading tool, likely forking from some other legitimate previously deployed tool, and waiting for some time, several months in this case, to build up a user base and then publish malicious version to them. What was also interesting is that on day or two after the initial version of this package was published to PyPI, the developer behind this package tried to retake another already existing PyPI package named Pay. So they were likely trying to make a more sound name. So it's probably more likely someone will use a package named Pay than AICOPA, or however you spell it.
Right. Well, how was the malicious code injected into the PyPI package without being added to the GitHub repository?
Well, that's not really hard to do. In most cases, the developer don't set up automated publishing to GitHub, and you can separate your publishing process if you control your publishing process, you can separate it however you wish. So you have PyPI access tokens, you can publish source code to GitHub, and then take your source code, add some malicious code to it, package it to the PyPI package format, and publish that version to PyPI. It's not something we have never seen before. Often there were crypto miners in npm packages which didn't have the crypto mining functionality in GitHub repository source code, because somebody expects that you will take a look at their source code and you won't find that. And threat actors know that it's harder to analyze compiled packages, in this case PyPI packages, which are in binary format, than to look at source code on GitHub, which is created to make it as comfortable as possible to perform code review.
Can you help us understand how your use of differential analysis between those package versions helped reveal the malicious behavior?
Yeah, well, indicator behaviors are proprietary technology, and they are based on observing some low set of behaviors and creating threat hunting rules based on them. So basically, what you do, you take a PyPI package through a static analysis engine, and it extracts indicator behaviors. That's how we call them. So they're basically text written descriptions of what the code does. So if some part of code uses some of HTTP libraries, it will say, okay, this code is capable of performing, I don't know, HTTP requests. In this case, what we had behavior indicators for decoding data with base64 algorithm and importing of zlib module, which is used for zlib compression and decompression. And we also had unusually long strings present in the source code. So those three indicators on their own aren't necessarily suspicious, but when you put them together, and above that you have expression execution in the code, that's something that you want to look at. And differential behavior analysis is the feature of our tool which enables you to give two package versions to the engine tool, and it performs that comparison based on file level. So it takes equally named files on equal paths from both of packages. So like in GitHub, you have version diff on the source code. In this case, you have version diff on behaviors, extracted behaviors. So basically, it compares same files from two different versions of the package and tells you what behaviors have changed in those files. You don't have to understand source code to get a sense of what's happening, what behavior has been introduced in your version. So somebody perhaps wouldn't know what requests library does. This way, you have easy textual explanation, which tells you, okay, this is used to perform HTTP requests. So basically, you compare two versions of package and have and gives you a way to see what behaviors have been introduced in a new version.
We'll be right back. Well, looking at the potential impact here, I mean, what was the harm that this package could have caused had you all not discovered it?
Well, basically, it could result in financial loss for the users who installed this package and used it in their projects. So basically, it's stealing of cryptocurrencies.
And what sort of insights does this research give everyone on some of the risks of relying on open source repositories in the software supply chain?
Well, the risks are emerging on yearly basis. It's not just the amount of malware present there, but it's also the level of sophistication that we see each new year. A year ago, the main attack vector was typosquatting, and let's say the malicious actor didn't put a lot of effort to develop sophisticated malicious packages. So they just hope that somebody will hop onto their package and get it installed. As the time passes, the attackers get more sophisticated. We have seen two really sophisticated attacks the last 2 weeks targeting cryptocurrency and artificial intelligence ML tools, Ultralytics and Solana, web packages on NPM and PyPI, respectively. So in those cases, the build environments were compromised, and that type of attacks were even harder to detect. And since they have a big user base, like I don't know, Ultralytics package was downloaded in, let's say, 60 million downloads, I believe. That's a big user base to quickly deploy your malware to, and that's a pretty high risk. And in this case, even smaller package projects which quickly grow user community are also a good vector to infect a big number of users in with low effort and almost no cost. Basically, you don't need to uh, either host your infrastructure. You can use open source package repository for distribution. You can use GitHub for data exfiltration or Dropbox or anything and tools that can be used to upload or download files.
Well, what was the process of reporting this package to PyPI, and how did they respond?
Well, the PyPI community and people behind it invest a lot of time to improve the security of the entire ecosystems. And I believe somewhere in the January, February, or March of this year, they introduced a reporting feature to their package repository. So basically, you have a button where you can report malware and point to the line of code where you have found malware in, and they put that package into quarantine until they determine if the package is truly malicious or it was false positive reporting. And their response was quick. I believe in just a few hours the package was quarantined, and in a few days later it was removed. And we had really good communication with the security team behind that product.
That's good to hear.
Yes.
What are your recommendations then? I mean, based on the research here, what should people do to better protect themselves?
Well, as I said, there are various package repositories. Not all package repositories put the same effort into improving security environment they operate in. So basically, on most repositories, it's up to you to make sure that something you're installing is not malicious. You should double check everything you have in your code base. So basically, uh, security vet everything you plan to use from open source package repositories, because even trustworthy packages with millions of downloads can quickly become malicious if somebody compromises either deployment account or deployment environment. So you can't have trust based on good reputation. It's not enough anymore. There are too many compromises already happened. You need to perform security vetting from your side. If you don't have enough resources or secure knowledge, you should use dedicated tools to perform that security vetting. ReversingLabs has Spectra Assure for Community, which is a free repository where you can see and check if there is anything known malicious about some package. You can go there and check it. If you use hundreds or thousands of projects, you likely want to use some commercial tool or commercial version of a tool to double check that your dependencies are clear of malicious content, and also that you are not introducing some type of vulnerability to your software project. Because let's get real, projects are rarely built of one of two or two libraries. Usually those are dozens or tens or hundreds of open source library in the dependency tree, and it's hard for developer organization to security vet everything there is in your open source luggage.
Our thanks to Carlo Zanchi from ReversingLabs for joining us. The research is titled Malicious PyPI Crypto Pay Package Implants Info Stealer Code. We'll have a link in the show notes. We'd love to know what you think of this podcast. Your feedback ensures we deliver the insights that keep you a step ahead in the rapidly changing world of cybersecurity. If you like our show, please share a rating and review in your favorite podcast app. Please also fill out the survey in the show notes or send an email to cyberwire@n2k.com. We're privileged that N2K Cyberwire is part of the daily routine of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. N2K makes it easy for companies to optimize your biggest investment, your people. We make you smarter about your teams while making your teams smarter. Learn how at n2k.com. This episode was produced by Liz Stokes. We're mixed by Elliot Peltzman and Trey Hester. Our executive producer is Jennifer Eiben. Our executive editor is Brandon Karpf. Simone Petrella is our president. Peter Kilpie is our publisher. And I'm Dave Bittner. Thanks for listening. We'll see you back here next time.